Everyone, it is 25 from the hour, so let's get started. Before I introduce our next speaker, I just want to give a quick reminder to check out our sponsored booth, including Fiddler AIs, which you can navigate to by clicking the booth icon to your left. There you can learn more about the company and enter to win some amazing prizes, including a $100 Amazon gift card. Now, without further ado, I'd like to introduce our next speaker, Amit Paka. Amit is the co-founder and CPO of Fiddler AI, a machine learning monitoring company that empowers companies to efficiently monitor and troubleshoot ML models with explainable AI. Prior to founding Fiddler AI, Amit led the shopping app products team at Samsung and founded Parable, the creative photo network now part of the Samsung family. He also led PayPal's consumer in-store mobile payment launching innovations like hardware beacon payments, and have developed successful startup products, particularly in online advertising, which includes paid search, ad exchange, and display advertising. Amit has a passion for actualizing new concepts, building great teams, and pushing the envelope. He aims to leverage these skills to help define how AI can be fair, ethical, and responsible. Amit will be giving us a talk on building high-performance MLOps with ML monitoring and AI explainability. Please give a warm welcome in chat.
Sure, Peter, and excited to be here yet again at the annual conference. And this time, I'm going to go a little deeper into how do you build high-performance machine learning ops, specifically focusing on monitoring and explainability. So let's get started. I'll save some time at the end for questions. So please feel free to add questions on the chat. And if I do kind of see them during the presentation, I can kind of address them there, or I'll keep some time at the end. All right. A little bit about Fiddler. We were born 3 years back with the mission to build trust with AI. That's what brings the team together, and we love that in this new age where there's a lot of trust issues, we can come and help teams with it. And a solution that I'll be talking more about the approach of today is model performance management. How do you ensure that the models that you're releasing are meeting the performance needs of your team? And we'll touch on where explainability plays a role there. I'll start with the overview of the ML workflow. So what you see here are typical steps that a team takes as they're building machine learning models. You first train on labeled data, and then once you have a trained model, you validate these to make sure that they're meeting the needs of the team, meeting the needs of the use case. Finally, you deploy it. You'll see an offline stage of the workflow, which is to the left, and you'll see an online stage of the workflow, which is to the right. And so training validation is an offline process where the model is not serving traffic. And finally, when you validated that the model meets your needs, then you deploy it and serve predictions. And when it's doing that, then you monitor it to make sure that it's not having operational issues. And finally, if it is having operational issues, you then try to analyze it, and that feeds insights into what may be going wrong, so you can take those insights and improve the model, and that could feed into training. This could be new data coming in, and so on. So this is a typical machine learning workflow that we have today. And so there's this offline portion, which is when the model is not actually serving traffic, and then there's the online portion of this workflow. So the problem we'll be focusing on today is the performance problem. And so performance I use in quotes because performance can mean really, really, really different things to different teams. It could mean accuracy to a team. It could mean fairness to another team. It could be risk and transparency to another team. So ensuring that the model is meeting performance and maintaining those actual performance needs is a problem. And the reason that's the case is models can decay. They can lose their predictive power because they are trained on some data, and the data that they see in live can be different. and so they can decay, or they can run into operational issues. They can fail silently, and so that can also impact the actual predictive power. And because of that, you don't just build one model, you build versions of the models constantly. You'll train a model, you'll deploy it, it'll work well for some time, it may lose its predictive power. Then you retrain another model, maybe change the model algorithm, revalidate, redeploy. So this workflow is very iterative. And because of this, you need visibility across the workflow, because you're not just working on one version of the model, multiple versions, and you're doing kind of comparative like assessments. And in the context of this workflow that is truly iterative, the models that you're building, they are increasingly complex. So no longer are these models simple models. They can be complex models, deep learning models also. Because they're opaque, it makes it very hard for teams to go through this life cycle and really understand how the models are working. And so you need this knowledge of model behavior if you want to address the performance problem. And so if you don't have visibility into the workflow and understanding of the model behavior, then your machine learning driven metrics, whether you're like a recommendation model, like really whether you have a recommendation model that's actually driving your commerce recommendations, whether it's driving your ranking and like relevancing of your feed, right? If you don't manage the performance, then the actual metrics are being impacted. So you're losing money if you're not managing your model performance. And so I wanted to introduce the notion of model performance management, or MPM. And so in this world of like MLOps lifecycle that I just introduced, where does MPM fit in? So the way you view MPM is it's a layer that sits on top of your MLOps like lifecycle, and it ensures that you have full visibility into all the aspects of your model as it's going from one part of the workflow to another, and giving you insights and helping you run these models at the highest performance, right? So let's look at a few examples of how it helps in each stage, right? In the train stage, you can log your training and test data, and you can check your model for bias, right? And then in the validation stage, you can actually bring in the model into an MPM system. You can explain why the performance or the accuracy is high. You can probe the model into regions of data and see why is that region of lower performance. And you can do this in the context of multiple versions. So let's say you have a champion model that you've already probed for a slice of lower performance. Now you've got a challenger model that you can again see, okay, is that same region still having lower performance? So this you can use MPM in the context of this iterative workflow. And within deployment step, you can record all the traffic that your model is serving. And you can, of course, compare champion challenger if you want to get confidence with the challenger before you actually deploy it. And then monitor these models, whether just the champion or champion and challenger, to observe how is the performance moving. Whether you have labels or not, you can use drift, and we're going to talk about that a little bit. How are model outliers behaving? How's the model doing in the context of bias, if that is relevant to your use case? And alerts, setting the right alerts on the right metrics for the right thresholds and the right regions of data. And finally, if there is an issue that has been alerted on, like using MPM to deep dive into understanding why that may be happening, whether it is an outlier, whether it's a drift. And we'll actually walk through an example of some ways in which you could root cause a performance issue. So like model performance management is this layer sitting on top of your machine learning ops lifecycle, helping you ensure that your models are running at highest performance, whether you're running one model or whether you're running multiple versions of the model. So what are some of the pillars of model performance management? There's three key kind of pillars that feed into each other. One is monitoring, right? This is ensuring that you have visibility into operational issues that your model is facing, whether it's drift, whether it's data integrity issues, whether it's outliers, whether it's just tracking performance metric. The second pillar is explainability. And this is deep diving into not just the what's going wrong, but why it's going wrong, truly understanding the model behavior, not just at the inference level, but also at a region segment level and at the global level. And lastly, fairness, where you're looking at the model performance in the context of fairness, right? Does the model have is the model trying to amplify bias? Is the model adding bias, right, to what may be existing already in the data that you use to train it, right? And the ability to be able to like really assess the model through in the lens of fairness through the MLOps lifecycle. Both these, all three of these pillars contribute to model performance management, and we've kind of deep dive into each of these. Let's start with drift. Why does drift matter? So when you train a machine learning model, you're using fixed training sets. And so the model is learning from these relationships of this training set. And it then actually generalizes what it's learned to new data that it may not have seen, right? But what it assumes is the new data is similar to the data that it's already been trained on. For example, let's use a lending case. If you've trained a lending model on users and loans in the US, then that model can make good predictions of loans made in the US. But if you take the same model and deploy it in Canada, right, the data is different. The model will not have the same kind of predictive power. And so when you deploy the model into production, the data can differ. And this could be due to changing data trends, and that results in performance of the model going down. And that's the key. So when the data shifts from what you train the model with, then the model performance goes down. And so you have to get ahead of this. And we saw some very key examples of this at the start of the pandemic, where user shopping behavior changed. And so there were these recommendation models that were being used to recommend products to users to buy. And they completely shifted. The accuracy of these models from a few of the articles went down by a third, because people were not really buying what they were buying before the pandemic versus after the pandemic. And so drift metric captures this variance and acts as a leading indicator. So like, let's say you don't have labels. You can use drift as a leading indicator that your model performance is going down. It's used to reinform when the model might need to be retrained, right? It could also be used as a measure of when you might be having some other issues in your data pipeline happening that might show up as drift. How do you measure drift? And so what you're seeing here is you're seeing a data shape, a data distribution on the left side. This is a baseline. And you're seeing a data distribution on the right side. This is what you're seeing in the production, right? And so drift really means how close are these data distributions to each other, or how far are they? If they're identical, then there's zero drift. But if they're very far apart, then there's high drift. So the way to measure drift is, the first thing is you have to find a baseline. And this baseline needs to be representative of what your model will see in production. And so that's the key thing. The baseline has to be representative of what you're seeing in production, of course, because you want your model's data not to deviate a whole lot. And so there's multiple metrics that help you calculate these. And some of these kind of popular metrics are JS divergence, which is a symmetric kind of statistical measure. There's also population stability index that's used in the financial services, scale divergence, and so on. You can also go all the way up to like really complex model-based techniques, which can tell you accurately what the drift is. And so these are some of the ways to measure it, but you need a baseline to compare against production. How different are these data distributions? And so, of course, when you do that, some of the challenges that you run into when you want to measure drift is there are two key kind of configuration challenges. One is, how do you accurately capture drift with this baseline? Where do you get this baseline from? And so some of the challenges are that the baseline can change over time, right? Let's say you use a static baseline. Your production data can keep on changing like slightly, right? And so you've got to have a way where you're changing the baseline over time. It could also be that when you're launching, you don't have good kind of production data, so you launch with something static. And then as you get new production data, you use a part of that to use as a baseline. Then the next thing that can happen is just kind of looking at what kind of drifts can the model like run into. One is the drift can be one time. It could be that a data integrity issue that caused a missing value to be imputed as really something else could show up as drift. And once that's fixed, the drift goes away. It could be one time. There could be recurring drift, and recurring drift could be something as simple as, hey, you have certain types of data distribution during weekdays and certain types in weekends, right? So you have like recurring, or it could be gradual. Like you can see the user behavior changing gradually over time. So there's three kinds of drift. And the so the third thing that you need to account for in the context of the baseline is you could have a use case with labels that have high class imbalances. For example, you could have an anti-fraud use case where like you could have one fraud example in your baseline and 9,999 non-fraud examples, right? So is that really a representative baseline? So you might have to weight the actual minority class and over-index on that when you're preparing a baseline, so it's representative and can give you a good read. Then you also need to account for variances in the drift, right? So for example, like let's say if I'm trying to measure daily drift, right, and I'm using a static, if I'm using a static baseline, then there might be trends Monday, Tuesday, Wednesday, which might be different than trends over the weekend, right? So you'll see variances in drift if you use a static baseline and you're looking at it from a daily kind of lens. So it could be that you can look at it from a weekly lens, where week over week it's stable, and so you have a baseline at a week level. Or it could be that you use a rolling baseline where you compare a Monday to a Monday, a Tuesday to a Tuesday, so that you have a good read with a representative baseline when there's variances in drifts. The second configuration challenge is, how do you identify steady state drift, right? So so in this case, like, what is the threshold that you should get alerted on? So like in this case, what you're seeing in this dark blue line is this is the actual drift. And you can see like in this last kind of window that the dark blue line like goes up. And how do you know that you should be alerted on the basis of the spike? So typically one way to do it is you have a training set, test set, and you find the drift. You just find a drift measure and you use that as like a threshold that you can set your actual alerts on. It could also be that because this is a new use case, you don't have like enough data. You could use a trial and error like method where you're running drift for a certain amount of time and you're trying to analyze the drift that you see. What's a steady state drift? Is that the normal drift? And then you use that as like a threshold. If that deviates from there, you can set a threshold to send you an alert. So those are two kind of typical ways that teams identify what is the drift measure to use if you're setting an alert. How do you resolve drift issues? Step one is you have an alert. You can either so you can either detect this anomaly visually, or you have some kind of anomaly detection, or you have you've actually set up some kind of alert that tells you that there is an issue. So in this case, we're looking at that last day of data when there's a spike in this dark blue line, which is drift. And then when the second thing is, if you want to look at if there's true drift in the model, you start with the drift in the output of the model rather than seeing drift across all the features, trying to figure out, is there truly drift happening? So that's a good measure to see, is there truly drift happening in like a model? You start with the output drift of the model. So this dark blue line is the output, which is probability churn. So you start with the output to see if the output has drifted. And then if it has, then you drill down into which are the corresponding features within the time bin have actually drifted. And here you could have hundreds of features. So what's the best way to figure out which feature might be causing it? So in this case, you could use explainability, and specifically you could use feature impact. How important is this feature to the model? So if the feature has actually drifted, and if the feature is also important to the model, then the combination of that tells you how much it's contributing to the drift in the output of the model. And once you have that detail, then you can drill down into it, and you can then root cause into that day's worth of data using the notion that number of products is the one that's causing the drift, and kind of drill down further. Segment monitoring, so now going past drift a little bit, in case of segment monitoring, the reason to capture segment and how they're doing is sometimes measuring something globally might mask things, or it might be that you might have a segment of interest that's of business importance, or that's been an area of issue. So you can monitor something. You can monitor a segment on demand, or you can predefine it, and you can see how does the segment do in the context of the model. How like different are the metrics? And if you have multiple segments, how does the segment do as compared to others? What you're seeing here is it's trying to compare attrition of employees, and it's trying to compare attrition of employees across different like actual departments. And so this helps you like really understand how a region of the data is doing. Yeah, champion versus challenger. Once you have a model running in live mode, and you have a challenger coming in that you're looking to replace the champion with, you can run them side by side, and you can run it in a replay mode or it can get shadow traffic, and then in real time you can compare the performance. In this case, the dark blue lines of the two models, you can actually compare side by side to see how is the new model doing in the context of the old model, and then you can deep dive into what is the difference between the new model in the context of the old model, so you can get confidence as you replace one with the other. Let's go into data integrity a little bit, and then we can wrap up with explainability. So why does data integrity matter? Your model can see a lot of data errors over its lifetime for a whole lot of reasons. And these data errors can slowly eat away at your model performance, or it could, if it's like a key feature, it can even tank your model performance. And so there's so many ways that data issues can be brought into the system. And these are data issues which may be hard to catch upstream, and it may be hard to analyze them upstream if you don't have the context of the model. Here's a few examples, right? So you've got a merchant ID that's null, right? So it's a missing value. You've got a transaction amount that's -40. That's not a legitimate transaction amount. Or you've got a zip code where you're actually seeing a string when the model is like expecting like some kind of int. So what would happen in this case? So how does bad data get handled today? And here's another example. You've got a transaction ID, like your model is seeing all these, it's trying to do anti-fraud kind of checks, and it sees the transaction ID and it's not a number. What does the model do? There's 5 ways that teams handle this today. One is you can discard the inference request, right? You can say, okay, if it's a key input that we need and it cannot be null, then we don't want the model to make an inference, right? This may not be an option if you have a critical, like a critical use case. The second thing you can do is you can impute a value. Let's say merchant ID is null. what can it be? What should it be? You can impute it based on, let's say, if it's a high enough transaction, maybe it's like a jewelry store, and you know which merchant ID that is, so you can impute it. You could also default it. Like, let's say you don't have an age, you could put a default age, which is an average age. That's also an option. Fourth is, if you don't have the data, you could acquire missing data in real time. We've seen this in high value use cases like lending, where there's insufficient data, and in real time data gets augmented. And so this is typically not the common use case. We've seen that in a few, but yeah, that is. I can take these questions online. I don't know, Peter, if you have time, since we are running over.
Yeah. Thank you, Amit, for the insightful talk. We definitely do have some time. So if you guys have more questions, type them in chat. But so we could start off with the first question, which is, can you have a model to predict the drift?
Yes, that's a great question. So there is, so you can measure drift using statistical techniques, using JS divergence, KS divergence, so on. You can also have a model to actually predict the drift. We've kind of done this in the past, where you train a model on the data distribution it should see, and then when you give it a new data distribution, it tells you how close the new data distribution is to the previous one. What we found is that the model output is, like, while it may be more accurate, it's hard to reason about. It runs into the same problem of model explainability. Why is the model saying the drift is closer or really farther away? And so we have leaned in on statistical measures that kind of machine learning teams are more comfortable with. In this case, KS divergence, JS divergence, and PSI.
I see. So our next question would be, how do we approach modeling data that is imbalanced, oversampling the minority of classes, or do nothing because the test or target domain also has a similar distribution? Doing so will cause drift.
Yeah. So what we have learned from customers who have use cases like anti-fraud that have minority classes, or like a very lower, like low kind of balance of minority class, is that you have to oversample the minority class in your baseline, or you have to weight it in like a different way. So there's two approaches. You can oversample, or you weight the minority class with a much higher weight. So when you do a comparison of drift, it accounts for the weight of the minority class. And kind of typically, like within kind of production, you would also see fewer examples of these, right? So you need to do the same. You need to do the same weighting of the minority class in like production, because at times it might not be an option to do oversampling of the minority class within production, because you only have so many samples coming in. So yeah, you need to one of those kind of two things, else your drift measure will actually vary widely, and you may not get a good measure.
And I guess speaking a bit about on the topic of data drift, when is it that maybe we do get alerts about a data drift, but then it doesn't actually affect the model significantly? And is that something to be concerned about, that perhaps it's over prioritizing certain features?
Yeah, that's a good question. I think sorry for the noise. For some reason, we just happen to have work nearby. So it's possible that you could have spurious drift, right? I think that's where, like, the team kind of measuring drift needs to find a stable baseline, right? So you can account for the variances in drift. And at times, I think it's still possible you may have spurious drift, which if you have a quick way to identify that it is spurious, you can kind of typically move on. It's an incredibly hard problem to figure out what is true drift versus what is not drift, given it's use case dependent, given it's like it's a reality of data dependent, and that can shift over time. So the value of having more accurate drift with the right threshold is still a lot more, even in the context of a few spurious like drift alerts.
So ultimately, there is a level of, I guess, trial and error, and also it's also something that we're still learning about as well. So I guess my next question is regarding, I guess, you mentioned ML model explainability, data integrity, and also data drift. Which of those three areas do you think companies are, doing a great job prioritizing? And then which one of those three areas do you think companies might actually need to refocus and focus more into?
Yeah, that's a great question. I think in the last 3 years that we've been approaching this kind of problem, we see an increased awareness of drift in the last year. Like last year, when we would go to customers, they would ask us what's drift, and now customers tell us, hey, we want drift, and we want concept drift, or we want feature drift, or certain kind of statistical measures that they're looking for. So there is an increased awareness of using drift measures, but I think what kind of customers need to really focus on more is how do you identify drift and how do you resolve drift? And I think that's like the next layer of kind of peeling the onion. Teams are aware that drift can be used to identify if your model performance is going down, especially in the context of like lack of labels. That's one. I think the second thing I wanted to highlight is, while explainability is a pretty hot topic, there is typically a lack of understanding of what comprises explainability and how it can be used. So I think teams are just about ramping up on, like, for example, you can use Shapley values to explain one model inference, and how can you use that explanation in your process, right, to bring transparency or improve the model. So I think explainability is still while the topic is well known, its applicability and the details around its applicability are still being kind of ramped up. And I would encourage teams to kind of look at how they can use explainability within their workflow to just bring transparency, to kind of troubleshoot, to reduce risk in their models being deployed.
I definitely agree in terms of explainability. It's a hot topic, but it's also an area that, what you mentioned, it's bringing transparency, and one of the hesitations for certain companies in working in highly regulated fields to kind of slowing down their ML adoption as well. So yeah, definitely an area to kind of focus more on. I think
Yeah, I just wanted to make a final point. I think teams also, sometimes they think if they just have an interpretable model, inherently interpretable, you don't need explainability, but you still need to explain the model holistically and see how the model is doing globally or at a segment level, cohort level, right? So explainability still adds a lot of value, even when you're building inherently interpretable models, not just to help understand and validate the model, but also share that understanding with like the rest of the stakeholders on the team.
Definitely. Yep. So I think that's it for the questions. Thank you so much, Amit, for joining us today.
Sounds good. Thanks for having me, Peter. And yeah, if you have any questions, feel free to reach out to me. My email address is right on the slide, amit@fiddler.ai.
Awesome. And thank you everyone for joining us as well. Have a great day. Bye.